So let's see how we can make MATLAB do the heavy lifting for us. What we have on the left here is the table that tells us what the probabilities are of different kinds of weather tomorrow, depending on what the weather is like today. What we just learned in the last video is that we should translate that into a matrix that's called the transition matrix. So there we have the matrix P. Now, we then look outside the window and we see that it's cloudy. And the way we say that today is cloudy is by setting x0, the vector that tells us what the weather is on day 0, to the vector 0, 1, 0. Okay, if we now want the vector that predicts the weather tomorrow, what we do is we create a vector x1 equal to p times x0. And x1 now is the vector that tells us that there's a 30% chance of it being sunny tomorrow, 30% cloudy, and 40% rainy. If we want to go to the day after tomorrow, then we take the predictions for tomorrow and multiply those by the transition matrix. So x2 becomes p times x1. That's the vector that tells us what the various probabilities are for the day after tomorrow, day 2. We can go to day 3. 4, 5, 6, 7. And there we have it. Now clearly this is a little bit tiring. If we want to go to the weather 3 weeks from now, we would have to do an awful lot of typing. So this is where we may want to write a little loop. So we may want to say that x is equal to 0, 1, 0. Today is cloudy. And we may then want to say for I equals 1 through 7, print out what I is. That tells us what day we're talking about. And then what the weather is like on that day, and we can simply overwrite the vector x with the prediction for day I. And notice that we get all of the intermediate results along the way, and let's make sure that that's the same as the x7 that we computed before, and it is. So now we have a means by which we could actually predict the weather a year from now. Let's see, how could we do that? Well, so how could we do that? Well, we could say for I, so we could go back to setting x equal to the fact that today is cloudy. We could then write our loop for I equals 1 through 365. We'll assume it's not a leap year. We can print out I and x equal to p times x. If we then say end, that's the end of the loop. It executes, and we find out what the prediction is for the weather a year from now. Now, one thing that's interesting is that going from one day before a year from now to a year from now, the prediction doesn't change very much. So notice that this means that vector x now holds approximately the prediction for what typical weather might be. We can also ask the question, what is the most likely weather? And notice that by looking at this here, we see that we have approximately a 42% chance of it being cloudy, a 31% chance of it being rainy, and a 26% chance of it being sunny. So, the most frequently encountered weather is predicted to be cloudy. So these kinds of techniques are actually used by, for example, the Google PageRank algorithm to determine which website is actually the most important one. Now, going into details for that goes beyond this course, but I thought I'd just mention them. Now here's another thing that's kind of interesting. What if we take this vector x and let's call it vector x365 and let's put that away. We could go back and say, well, what if today it is actually sunny? So we use a different unit basis vector. We could then write our loop again and see what the predicted weather is a year from now instead. You may want to stop here for a second and think about this. What do you suppose it might be? Well, we again print out I. We print out x equal to p times x, and this executes it. That's interesting. That vector looks kind of familiar. Again, it's approximately a 42% chance that it's cloudy. Let's compare that to the vector that we stored away. And you notice that they are equal. So what's going on there? Well, that's the simple observation that if the vector x365 gives you the typical weather at this location, then what the weather is today should not really change what the typical weather is. So whether you start with it today being sunny or cloudy shouldn't change what the vector that tells you what typical weather is. Later in the course we are going to revisit this example and relate it to eigenvalues and eigenvectors, and a method that's known as the power method.